students! Today we will continue to learn from where we left off in the last class. Let's take a look at the first step in machine learning, which is data preprocessing. So, why do we have to preprocess data? We know that the original sample that we obtained often has problems such as missing values and duplicates, which needs to be addressed before we can use the data for machine learning. There's no standard process for data preprocessing, but it generally involves 6 steps. The first step is to remove unique attributes that don't provide any useful information. The second step is to process missing value, which involves either inputting the missing values or removing the rows or columns with missing value. The third step is attribute coding, which means converting categorical data into numeric data. The fourth step is data standardization, which involves scanning the data to common scales to prevent any features from dominating the others. The fifth step is feature selection, which is the process of selecting the most relevant features for the model. Finally, the sixth step is principal component analysis, which is a technique used to reduce the dimensionality of the data while retaining the most of its important information. Here, we can see a brief overview of machine learning process with our focus on data preprocessing. Data preprocessing mainly consists of feature extraction, data preprocessing, data standardization, and data dimensionality reduction. We will dive into each of these parts in more details later on. So far, we can see that the process of data preprocessing may seem monotonous and dull, but it is so incredibly important. It sets the foundations for the accuracies and effectiveness of machine learning model and can greatly impact on its performance. Dealing with sample data, it's important to eliminate the fluence of different magnitudes between feature attributes. The difference in magnitudes can lead to the dominance of attributes with larger order of magnitudes, which can affect the performance of the model. It can also cause the convergence of speed of iterations to slow down, which can increase the time it takes to train the model. Furthermore, algorithms that depend on the distance between samples are very sensitive to the orders of magnitude. This includes classification and clustering algorithms, which can be impacted by the scale of the data. Therefore, data stabilization is crucial in ensuring that the machine learning model is accurate and effective. There are 2 common methods used for data standardization. The first method is min-max standardization, also known as normalization. In this method, new data is calculated by subtracting the minimum values of original data and then dividing it by the range of original data, maximum minus minimum. This scales the data to a range of 0 to 1.
The second method is the core
standardization, also known as normalization. In this method, the new data is calculated by subtracting the mean value of the original data and then divided by the standard deviation of the original data. This scales the data to have the mean of 0 and standard deviations of 1. Both of this method are commonly used in machine learning to standardize the data and remove any influence of the original's data scale. we may wonder how to choose between standardization or normalization in data preprocessing. Here are some requirements that we need to follow. Standardization is preferred when the distribution of the sample data follows a normal distribution.
On the other hand, normalization can lead to
quasi-circular distribution of normalized data, which can have advantages in certain situations. However, normalization has some disadvantages. It is very sensitive to outliers, because outliers can affect the max or mean values. Additionally, when new data is added, the max and mean values may change greatly, which can impact the normalization result. In contrast, standardization has little impact on the mean value and standard deviation with the addition of the zoo data. So, when deciding between standardization and normalization, it is important to consider the data distribution, percent of outliers, and the impact of new data. Ultimately, the goal is to choose the method that will result in effective machine learning models. We are talking about data preprocessing here. Specifically, something called data dimension reduction. So, dimension in this context is all about the number of feature attributes we've got in our sample set. And when we say dimension reduction, we're talking about shrinking down the numbers of features in that feature max matrix. Basically, it's all about trimming the fat and keeping only the most important stuff. So, here's what we're looking at. Picture a two-dimensional graph with right-angle coordinate system. You see that in the first quadrant, there are a bunch of data points hang out between the x1 and
x2 axis.
To describe this point, we need to use both coordinates. Now, you look at the second graph. We've given the coordinate axis in a little twist. By doing this, most of the points end up close to one axis. This let us just one axis to represent the most of the information about this point. And that's a great trick to cut down on the amounts of information we need to describe them. Next up, we're diving a bit deeper into this dimension reduction stuff. One of the most popular method is to do this is something called principal component analysis, or for short, PCA. Now, if you're using scikit-learn, a super handy Python libraries for machine learning, you're in luck. They've got a PCA class tucked away in there, the composition module, all ready to help you implement this PCA magic.